Okay, I think it's already recording. Hello, today we're going to use the quadratic formula and the discriminant. Um, this book is a little written in, but I'm going to write more. The quadratic formula is hanging in my room. Hopefully you've used it before, but the discriminant is part of the quadratic formula. It is b squared minus 4ac, that part, not the square root of it, that part. Here is the quadratic formula, which will give you your x-intercepts, and it is made up of the axis of symmetry right there, and then plus and minus square root, always plus and minus, the discriminant. Notice that's all over 2a. I just wrote it by here so you could recognize that's axis of symmetry, but there's a whole numerator, and then the denominator is just 2 times a. So let's do example 1. At the World Championship Pumpkin Chunkin contest, pumpkins are launched hundreds of yards. The path of a pumpkin can be modeled by this. H is the height, and T is the number of seconds after launch. This is a great problem because we're going to be doing a project that will count as a quiz, and it is similar to this. So use the quadratic formula to solve this. So my suggestion to you is always write out A, B, and C. If you don't write it out and you do something wrong and it's an assessment, that will not help you. I also think you should write it out like this. I'm sorry about the blue pen. Write it out like this. Negative b, so we're going to take the opposite of b squared. Now this b is positive, but I know and you know that whenever I square a number, it's going to be a positive. So if this is actually a negative, I don't even mess with the negative right here in this part because I know it will be a positive. Okay? If you are going to square a negative, you have to do that because that will give you 9 in the calculator. I'm going to do this side note. If you do this in the calculator, your calculator knows PEMDAS and exponents is before multiplication, so this is actually a negative 9. All right, then 2 ways you could approach this. You could do all of this plus divide by negative 32, and then all of this with the minus divide by negative 32. Another way you could do it is work the inside of this, which is not even to this point. I would just do this, which I'll do right now, 124, that's where our decimal came from, squared minus 4 times negative 16 times 42. Now on my calculator, negative is to the right and negative is under the 3 and minus is to the right of 3. This is a minus, this is a negative, and the negatives are a little shorter in my calculator. So I get this number. Now from here, unless this is a perfect square, you may leave it right here for me. That is fine. You could also keep on going and do the seconds. There is, I know the answer is 8.1 and 0.3 negative. Okay, those are our 2 answers for the pumpkins. Now we know we can't have a negative time, so it lands, the answer is 8.1. Let me show you in a sketch exactly what's going on. So I guess I'll come up here. Here's our graph. I'm only putting the first quadrant because it is a real life situation. I'm saying it lands at 8.1, but I also had this negative 0.30. I know my y-intercept is my c, which is 42. So I know it's going to go like this and then back down like that. But since it is a real life problem, we only really have this area here. You don't have to shade these problems, I'm just doing it to show you where it applies. This right here, 42 feet, because it's height in feet, this is height, this is time. 42 feet is the height of the launcher. So if it was a parabola, we do have a beginning point and an ending point, but since it's a real life problem, it's starting 42 feet up in the air at time 0. I'm not going to do the diver example. Let's go to when c is negative. Oh, I'm not going to do this one either. I wish they would do one where b is negative because that really changes it. But remember, you take the opposite of b regardless. Positive, you're going to write a negative. If negative, you're going to write a positive there. We could do the check though. A is 3, b is negative 5, and c is negative 1. So x is 2 times a, the opposite of b. Now this is where I'm saying you could write b squared, so negative 5 squared. You could write 5 squared because it's going to be positive. But when I'm doing this, I know negative 5 squared is 25. So you could write for the 25, you could put this, or you could put this. Or you could put 25. Minus 4 times a times c. So if you notice, this is going to be a negative and a minus, which is going to be a plus. So I'm going to get 5 plus or minus all over 6, 25 plus 12, which is the square root of 37. You may leave it like that. You only need the decimals if you are graphing, or if it specifically says to find the answer in a decimal. Like that time one with the pumpkins, you should get a decimal to know exactly the time. This tells you nothing. Okay, here is complex roots, example 3. So using the quadratic formula again, we have a is 5, oops, right here. B is 8 and c is 11. So we take the opposite of b, so negative 8, b squared minus 4 times a times c divided by 2a. When you do the inside of the radical, which you should in your calculator do the inside number, 8 squared minus 4 times 5 times 11. Because if you take the square root at once and you get something like this, it won't give you an answer. Because this means it's imaginary. So for me, you just need to make sure and take out that I, the square root of negative 1, and leave the 156 in there. That's an okay answer for me. They simplified it here, which would be the answer to a multiple choice test. Because there's our I, square root of 4, 4 times 39 is 156. So square root of 4 is 2. There's the I, square root of 39. Again, you could leave it like this. But on a multiple choice test, 2 goes into each one of these numbers. So 8 divided by 2 is 4. 2 divided by 2 is 1. 5 divided by 2. You would have this answer on a multiple choice test. You wouldn't have these choices. But for me, it is fine to leave it like that or like that. It's easy for me to grade it like that. Okay, let's do another one with imaginary. So A is 9, B is negative 3, C is 18. So you take 3, that's your negative B, plus or minus 2A is 18. 3 squared is 9 minus 4 times A times C. Now I could already tell that's going to be negative. I don't have my calculator out. So 36 times 18, 36 times 18, 639. I don't want to try to figure out the square that goes in there right now. So an answer of 3 plus or minus I squared of 639 over 18 is okay. All right, next we're going to talk about the discriminant. The discriminant is only the part in the square root, not including the square root, only the part in the square root, b squared minus 4ac. And what does that tell us? Well, since it is inside the square root, if I take the square root of a positive number, I get a plus or minus whatever the answer is. Like if I take the square root of 9, that's plus or minus 3. So there's two answers for that. If I take the square root of 0, that is just 0. So that would be one real answer, and I'll show you why. Because this part of the quadratic formula that would be 0, all you have left is negative b over 2a. So that would be one root, one x-intercept. And if I have a negative is a complex number, but again, you're going to have the plus and minus whatever I. So there's two complex roots with the negative. And it's all because of the square root. When I take the square root of negative, they're complex numbers. Take square root of 0, the square root drops out. If I take a square root of a positive, I get two answers. So here it shows this parabola. It could be any of them as long as you have two roots. The discriminant is positive. You get two irrational or rational. Anyway, you cross the x-axis twice. If it is 0, there's only one root, and that root is your axis of symmetry, b over 2a. Do you see how it's the one that crosses? It's on the x-axis. Now they are showing this parabola that opens downward, but we're just focusing on the x-intercepts, the roots. And if it is a negative, that is a complex number. It does not pass the x-axis. And so those are imaginary roots or imaginary zeros. Okay, so find the discriminant. We have a is 2, b is negative 10, and c is 7. So b squared is negative 10 squared. You could do that, but 10 times 10 is 100. Times 2 times 7, so 100 minus 56. Well, to find the discriminant and to figure out how many roots, I know 100 minus 56. I may not know the exact number. I do, but I know it's a positive. So since it's a positive, there are two real roots, or zeros, or x-intercepts, or solutions. Looking at this one, a is 2, b is 8, c is 8. So b squared minus 4 times 2 times 8. So this is 8 times 8, 64. 64 minus 64, it is 0. So there is one real root. You could cross out the s. Because we get negative b over 2a as our only solution. Because it's negative b over 2a plus or minus 0. So that part drops out. Square root of 0, 0. Complex numbers. A is negative 5, b is 10. You do it the same way. You're just going to get a negative. So we have b squared, 10 squared, again 100, minus 4, negative 5, negative 15. A negative, negative, negative is a negative again. So 100, it's negative 200. Either way, you know it's negative there. So there are two complex roots. I'm going to put zeros here. The next one is the same. I'm not going to do the last check. All right, let me know if you have any questions. Thank you.